Hello friends, my name is Nitin Usgare and I welcome you all to the course Machine Learning and Application for the Autumn semester. The evaluation system is displayed on your screen. The in-semester exam has the 30% weightage, whereas the end-semester exam has the 70% weightage. The reference book for this course will be the Pattern Classification by Duda, Hurt and Stork. You can refer the textbook of Machine Learning by Peter Flatch, Introduction to the Machine Learning by Ethan Alpedin, and Introduction to Statistical Learning by James Vitain, Haste, and Dipshurani. So let us move to the first unit, that is Introduction to the Machine Learning. Now this unit is mainly divided into three main topics, that is Introduction to the Machine Learning, Types of Machine Learning, and Dimensionality Reduction. So let us discuss the first topic, that is Introduction to Machine Learning. So why machine learning? Machine learning is required to solve many complex problems. It is not feasible to solve this complex problem by writing the traditional algorithms or programs. So the problems are divided into two types, the non-complex problem and the complex problem. So let us first discuss the non-complex problem. So given any n numbers, which may be real or integers, may be positive or negative. So our objective is to write an algorithm or program to output all input numbers in a sorted order. To solve sorting problem, first analyze what to be done. Think of some logic which can solve this problem. So any comparison-based logic can solve this problem. To design the algorithms, there are different algorithm design strategies. So depending upon the nature of input, a design strategy has to be selected. And according to the data structure and the algorithm design strategy, an algorithm will be created to solve the problem. Now such algorithm is called as the static or instruction-driven algorithm because the output to be produced depends on instruction. Now we'll come to the complex problem. So what are the complex problems? For example, writing an algorithm or to program to filter incoming email of any user as spam or non-spam can be a complex problem. Now let us discuss this example. Let's say that if incoming email has the word shopping, win prizes, discount offer, sales, then such emails should be filtered as spam for some user X. But this criteria may not result in correct filtering for the incoming email to user Y who loves the shopping, who wish to avail the discount offers, who wants to receive the notification of new sales. So now in this case, if any incoming email has the word shopping, win prizes, discount offer or sales, then such emails will be filtered as a spam for user Y. And in fact, for user Y, such email is not spam. Now consider another example. Now if you receive an email which is written in a Japanese language, then it should be filtered as a spam for you. But if you have trained a student of course in a Japanese language, then such email should not be filtered as a spam for your friend. So in these problems, we cannot think of universal logic or decision criterion to filter the incoming email as spam or ham for any user. Rather, we may think of an algorithm to solve this problem whose decision criteria must change according to the nature of incoming emails and the interest of users. So such algorithms are called as data-driven algorithms because the output to be produced, it depends on the kind of input data given. So in a nutshell, we can conclude that in this slide, machine learning is used when a human expertise does not exist. For example, the navigation of satellite on Mars in a situation where the humans are not able to explain their expertise. For example, the speech recognition. There are certain situations when solution changes in time. For example, updating a routing table in a dynamic computer networking, and so on and so forth. So, in nutshell, we can say that machine learning is used to solve or to give the solution to a complex problem where the human expertise does not exist. Okay. So let us move to next slide. What are the advantages of machine learning? So the advantages of the machine learning are listed here. The first advantage of machine learning is automated. Machine learning methods are automated processes which runs on input data and produces a model. Now this model can specify how to achieve the goal. So once the model is constructed, the test data can be given as an input to it to get the corresponding output. So which is shown in this figure. The input data is given to the machine learning method which generates the machine learning model, and to this machine learning model we have given the test data or the new data as an input to generate some output. Okay. The next advantage of machine learning is machine learning methods are faster because the time required by machine learning method to process the input data and to build the model is less than the time required by the programmer to write the program manually to achieve the goal in a complex problem. Additionally, for given test data, machine learning method produces the faster result. And that's the reason the machine learning models are always preferable for solving the complex problem over the manual. The third advantage of machine learning model is the accuracy. Machine learning methods are automated, therefore they can run longer, more and more data to make more accurate decisions. The fourth advantage is same machine learning methods can be used to solve the different problems. So machine learning methods can easily handle the increase in size of input data, and thus they are scalable. Those same machine learning method can be used to solve the different complex problem depending on the problem to problem. In consideration, the machine learning methods can be customized to achieve the different goals in a different problems. For example, same machine learning method can be used for handwriting recognition, for speech recognition, for email filtering, for detecting the fraud. So these are the advantages of machine learning model. Now let us see the definitions of machine learning. Now machine learning has a wide scope of application. So there are many definitions of machine learning. So to understand the machine learning, some of these definitions are given as follows. So from the Arthur Samuel's perspective, machine learning is the field of study that gives the computer the ability to learn without being explicitly programmed. Now, the most recently, the Tom Mitchell in 1997, uh, he has defined the machine learning as a computer program which is said to be learned from experience E with respect to some class of task T and the performance metric P. So its performance at task T is always measured by P, and this performance P is always improves with the experience E. So computer machines are targeted to solve some task T, and the performance of the computer program in solving this task T is measured with respect to metric P, and in case of machine learning, this metric is always called as the accuracy of your machine learning model. So here you can see that the input data or the sample data is given as an input to the machine learning method or the machine learning algorithm, which actually generates the machine learning model. And to this constructed machine learning model, we give the new data, which is completely different from our sample data or the input data, and we observe the output from this constructed model. Okay, and we infer some meaningful information from the output, which may be helpful to take some business decisions. Okay, so now we'll see what is the machine learning, why we use the machine learning. Now, machine learning is used to optimize the performance criterion using the example data, that is the sample data or the past experience. What is the role of statistics in machine learning? Yes, the role of statistics in machine learning is to infer the meaningful information from the sample data, wherein the role of computer science is to prepare or to construct or to use the efficient algorithm to solve the optimization problem and to evaluate the model to get some inference, to extract some meaningful information that really helps us to take the business decisions. Now we'll go to the applications of machine learning. So machine learning has the wide variety of application. The first application of machine learning is handwriting recognition problem. Now in this application, the input is handwriting samples with the correct output. Task T will be the recognition and the classification of handwritten words to correct English words. Performance P will be the percentage of words which are correctly classified. Another application of machine learning will be speech recognition, face detection. But on top of all these, a very important application of machine learning is the recommendation engine. Now let's try to understand this application with some example. Now suppose you are watching online videos on YouTube. Depending on your context and reviews by the other viewers, recommendation can be given by a machine learning algorithm to you for next video to be watched. So these recommendations are used in various applications such as job recommendations, a product recommendations, a book or the restaurant recommendation, a set of previously watched videos by you and other viewers along with their comments, and maybe to recommend a new video to you. So these are some examples of recommendation engine application of machine learning. A machine learning can also be used for the weather prediction. Machine learning can also be used in a retail domain. These are some examples of retail application of machine learning, like market basket analysis and customer relationship management. So what is market basket analysis? So market basket analysis is nothing but finding a relationship or the association between the items and the transactions. For example, given a set of purchase details by many customers, we have to conclude some rules. For example, if a person buys an ink pen, then the same person may also buys the ink bottle. Another example would be, if a person buys a bread, then the same person may also buy a milk. The next application of machine learning will be finance domain. For example, the fraud detection and the credit card scoring. So in fraud detection, given the history of credit card transaction, identify the transactions which may be fraudulent. Then the other example in the finance will be whether to approve the loan to the customer or not. How? So the problem statement of this application will be, given the history of customer and their repayment history of loan, decide for a new customer a loan should be approved or not, right? Then there are the other applications are like manufacturing, like controller in a conveyor belt to detect the faulty products or to detect the defects in the product, in the robotics automation, in troubleshooting, These are some examples of manufacturing application. In medical field, detecting the cancer cells, uh, diagnosing whether the patient has diabetes or not. These are some examples of medical applications. In telecommunication, detecting the spam filters, intrusion detections are some of the examples of machine learning application. And finally, web mining is one of the major application of machine learning, where the best example of web mining is the search engine. So now we'll try to see the examples of this application. I will show you in this slide. So the fingerprint image, this shows the fingerprint image. This is handwritten characters, detecting a handwritten character, detecting a fingerprint, detecting the human face, then recognizing the speech signals, so on and so forth. So these are some examples with respect to the first three applications. These are the recognition of printed characters, recognition of handwritten characters. These are the examples of printed characters and the handwritten character recognition. These are the examples of fingerprint, and you would be surprised that any human being's finger will come under this 8 different categories of fingerprints. So these are the 8 different categories of fingerprints. So first type of fingerprint category is the plain arc, second is tainted arc, right loop, left loop, accidental, pocket whirl, plain whirl, double loop, and so on. Okay, so you would be surprised that these are the 8 different types of fingerprints that any human being has. Apart from this application, there are some other applications of machine learning which comes under social media services, virtual personal assistant, online customer support, automatic translation of speech from one language to another language, video surveillance, that is detecting the humans, detecting the objects, suspicious activities, so on, firefighting robot, web spam, online fraud detection, product recommendation, and whatnot. So in summary, you can see that all these applications of machine learning, they have been categorized into the domains. And what are these domains? The machine learning applications in retail domain, in travel, in healthcare, in finance, and in the media. So I hope you would enjoy this video. So these are the references for this presentation. Thank you so much for watching this video very patiently. If you have any queries with respect to this video, please write to me at the usgare.nitin@kbtcoe.org, or you can reach me out at this phone numbers, these contact numbers. Thank you very much again for watching this video. See you soon in the next video. Thank you.